Hey guys, so welcome back. In this video, I'll be trying to solve the problem course schedule 2, which is the problem of the day on Geeks for Geeks on 1st November. All right. Now, before we start, let's take a moment to note that this question has been asked by Google, so it's a pretty good question to practice and solve. Okay. This is also a very basic question on graphs. So even if you're not too confident on graphs, this will be a very good starter for you. All right. Okay, you're given n courses. Okay, so basically what they're saying is that you're given n courses, you have certain prerequisites for each courses. This basically means that there are other courses you have to take in order to access a particular course. So I'll just give an example of that. Okay, say for example prerequisites. The first prerequisite given to you is x comma y. This basically means that if you want to take course X, you should have taken course Y already. Basically, if you didn't take course Y, you can't take course X. Okay, in a way, X is dependent on Y. Okay, now based on that, you have to find the correct ordering of courses in which we should, basically the correct ordering we should take to complete all the courses. They didn't ask us to find the ordering as such because you just have to output a Boolean value true or false. We have to just find out if we can take all the courses together or not. Okay, so now let's move on to the whiteboard. Okay, I copied both our sample inputs here. So let's go through the first input. Okay, this is a very standard input. Okay, so now we have 1 comma 0. This basically means that 1 is dependent on 0, right? So we can just draw a graph like this, for example, for now. Okay, now 1 arrow mark 0, this basically means that 1 is dependent on 0, right? Next, we have 2 comma 1. Basically, 2 is dependent on 1. Okay, as simple as that. Now, this graph has been built. Okay, now let's try to find out if we can access the courses or not. So I'll just start from course 2, for example. Okay, I'll start from course 2. When I go to course 2, I realize that I can't take course 2 unless I take course 1. Okay, and I know that I didn't take course 1 up till now, so I can't take course 2. So what I'll do is I will use DFS and I'll move forward. Okay, I'll move forward to course 1. This is a very important point that you guys got to understand that this is basically topological sorting. We are basically doing topological sort based on in degree and out degree. We are using DFS to move more and more inside till we find our answer. Okay, so now we go to 1. All right, now in 1 we know that 1 has a prerequisite of 0 and we didn't go to 0 yet. So we can't access 1 as well. So what do? We do DFS again. We go to 0. Now we go to 0, we see that 0 has no prerequisites of any sort. So we can take 0. Okay, so we will take 0, we'll recursively go back. Now we'll go back to 1. Now we see that 0 has been taken already, so we can access 1. So we'll take 1 as well. Then we'll again recursively go back to 2. We'll take 2 as well. As simple as that. Okay, that's how this works. Okay, so in this, your output should be true because all the courses can be accessed. Okay, so now I'll give you a small variation of this. Let's say, for example, 0 is dependent on 2. Say, for example, you have a cyclic relation like this. Is this solvable? See, let's start from 2 again. We start from 2. We have a prerequisite of 1. We don't have 1. So we'll go to 1 again. Okay, we'll do DFS. We'll go to 1. 1 has a prerequisite of 0. We didn't go to 0 yet. To 0 yet. I'm sorry. So we'll go to 0. Now what do? Now when we see that 0 has a prerequisite of 2, it seems weird, right? So now we go back to 2 and this cycle just keeps on looping on and on. So this basically has no solution. Okay, if you have no solution, you should output an empty array. Okay, so basically from this what we understand is that if your graph contains a cycle, it's not solvable. All right, so yeah, that's the first input what they gave you. Now let's discuss a bit more complex inputs. Okay, let's go to the second example what they gave. So now I already made this table for you guys, so it'll be much easier to understand what is going on. Okay, these are the few data structures what we'll use. Okay, we'll have two sets called visited and cycle. I'll be explaining what they do in a moment. Okay, we'll also be having a hash set. This hash set is basically used to store the prerequisites of each and every course, as simple as that. Okay, so now we go here. Okay, we see 2 comma 0. This basically means that 2 is dependent on 0, right? We have to take 0 in order to access 2. So we have 0 inside our hash set for 2. Then we see 2 comma 1. Then so because of that you already have 1 inside of a hash set for 2. Then we see the third course is dependent on the second course, right? So we inside a hash set for 3 we have 2. Okay. um yeah, so now we can construct a hash set first. Now this you can think of it as an adjacency matrix or adjacency list, what we use in DFS and VFS. That's basically what this hash set does. Okay, so let's draw the graph. Like, let's see how the graph will look like. All right. So let's see. 2 is dependent on 0, right? So I can just draw 2 and 0 here. 2 is also dependent on 1. Then 3 is dependent on 2. Now a graph will look something like this. Okay. So now let's start from the third course. Okay. Normally in our program, we'll always be starting from the beginning, like from course 0. But in this case, we'll just start from the third course so you guys can understand how the DFS works. Okay. Now we see that the third course is dependent on the second course, right? So we can't access the third course yet. So what do? We do DFS, we move forward. Okay. Now for the second course, we look at the hash set, we see that we need to have both 0 and 1 in our visited to be able to access course 2. But we don't, right? So we can't access course 2 as well. Now we do DFS on this as well. We can either go to 0 or 1. Now I'll go to 0 as an example. Okay. Now what do we see here? The hash set of 0 is empty, which means there are no prerequisites for 0. So we can directly add 0 inside our visited set. Okay, we access 0 now. Now what do? We backtrack. We backtrack to 2 and we see can we access 2 or not. Now inside 2, we have 0 and 1. We see that 0 is already inside our visited array. So that's good. Okay, but 1 is not there. So we still can't access 2. And I also forgot to say one thing. Visited stands for every single node which we visited within our entire graph, and cycle stands for the current path we are following right now. Okay, so in our current path, we went through 3, then we went to 2, then we went to 0 as well. Okay, all right. So as I said, we come back to 2, we see that the prerequisites for 2 are 0 and 1. We have 0, but we don't have 1. So what will we do? We'll do DFS on 2 again. We'll do DFS on 2, we'll reach 1. Then we again see that 1 has no prerequisites of any sort, right? So basically we can add 1 to our visited array as well, and it can also go inside our cycle. Okay, as simple as that. Now what? We backtrack to 2 again. We again check if 0 and 1 has been visited or not. Yes, they have been. So now we can add 2 inside our visited as well. Right. Then we backtrack to our third course and we see if we can access the third course or not. And yes, we can, because the only prerequisite for the third course is the second course. And we know that we have accessed that already. It's already in visited, so we can access the third course as well. That's basically it. Now you can return true as the answer. So now most of you might be thinking as to, hey, we only used the visited set in this. Why do we need the cycle set anyways? This cycle set, as the name suggests, it is used to check if a cycle is there or not. Okay, now scratch this example. Okay, scratch this example. I'll just take the example of earlier. Okay, I'm just gonna delete this. Okay, let's just say, I'll take a simple example. You have 1, you have 2, and you have 2 going back to 1 again. Okay, you'll go to 1. Okay, now 1 is dependent on 2, so we can't access 1 yet. In our cycle though, we'll add 1 because we went through 1 right now. Okay, then we'll go to 2. We go to 2, we see that we can't access 2 because 2 is dependent on 1. So into our cycle, we'll add 2. Then we go to 1 again. Okay, then we see that 1 is there in our cycle already. Now this basically means that there is an overlap, right? There is a cycle inside our graph. So we can instantly stop it and we can instantly return an empty array. That is the reason, that's the use of the cycle set inside of this. All right, as simple as that. Hopefully you guys understood. Let's move on to coding the solution out. Okay, so let's code it out. The first thing is we'll make a dictionary called prereq. This is basically to store all the prerequisites of our nodes, right? So I can just do course for empty list. This basically means that for every single course that is there, I have to put an empty list for that. All right, now this list, all our prerequisites will be stored inside this list. Okay, for a course in range n. Okay, as simple as that. So let's say we have 4 courses. We'll have 0 empty list, 1 empty list, and so on. Okay. Now we just created the list. We have to add the prerequisites inside of them, right? So we'll do for course, comma pre in prerequisites. This is what they gave us. All right. We can just add prerequisites of course. Let's correct this. Of course will be equal to, sorry, dot append pre. Okay. Now this will add the prerequisites inside their respective nodes, I should say. Okay. Now here is where we initialize our data structures. Okay, we have output as an empty list. All right. Then we have visited. As I said, this is used to keep a track of all the nodes visited and which is valid. Then we have cycle. All right. Now they both will be sets. Okay. Now we use a set because like the elements can't be duplicated inside of them, so we can instantly say if the number is getting repeated or not. All right. Now we'll create a DFS function. Now the DFS function will take a node, which is basically a course, as an argument. Okay. Now the first check we check is what? If course in cycle. What does this mean? This basically means that it's getting repeated, right? If a course is already there in cycle, as I said, we can instantly return false. It's instantly invalid. All right. Now, if course in visited, now this is not an issue. Okay, this is not an issue because if it is there in visited, there is no guarantee that it is there in the path we are following right now. So it's fine. We can just return true as the output. All right. What should be caps? True. Okay, now what do we do? Now we do cycle.add course. Cycle.add course. You have to add the current course or the current node we are going through into our current path. What is which is cycle. Okay. Now for pre in prereq, right? Basically, for every single prerequisites inside prerequisites, I should say, of the particular node that we are in, we have to go through all the prerequisites, right? We have to do DFS on all of them. So we can just write DFS of pre, as simple as that. Okay. And that's basically the end of it. So at the end, we can just remove the current node from cycle because our path is over. We have officially found an answer which is either yes or no, right? Visited dot add course because we visited the current node, we have to add it inside our visited array. Then output dot append course. We can append that to our output as well. Okay. Then we can just return true as the answer. That's basically it for our DFS function. Now all we have to do is call DFS of course for every single course which is there. Right. So if we have n equal to 4, we have course 0, 1, 2, 3. So for C in n, right? Sorry, for C in range n, because to go through all the numbers, right? We can just say if DFS of C is equal to false. This basically means that if a cycle is there, we can instantly return an empty list. Otherwise, we can keep on going with the DFS and return either true or false from any of these statements. All right, as simple as that. And now we just return output. The output can either be true or false. Yeah, we have to give the path and the system itself will decide if it's true or false. All right. So let's compile and run. Let's see if it works. Okay, we got a compilation error. Oh, it should be a return here, not just empty bracket. My bad. Let's see if it works now. Runtime error. Let's see if DFS good false. Yeah, it should basically be square brackets here. I forgot the prerequisite is the dictionary. I thought it was the list. Anyways, yeah, let's try it now. Let's check the indentation as well. Yeah, all right, let's check. And it works. Let's submit. Okay, so that's basically it. That's how you solve this problem. If you have any doubts, do leave them in the comment section down below. And that's it for this video. I'll see you in the next one. Goodbye.